Okay, we're doing chapter 1, number 73. This is a free fall problem. And it's a couple steps because we have a couple of falling objects here. We have the first rock being dropped a half second before the second. And I guess I would just like to change the wording of the question here because it says, with what initial velocity should he drop the second rock? Usually I associate dropping something with just letting go. And I would say he's going to have to throw it if it's going to have an initial velocity. Okay, so we're going to make a list of givens here. We have the first rock is dropped, so we're going to say that its initial velocity in the y direction is 0 meters per second. And its acceleration in the y direction is gravity, or the acceleration due to gravity. Here I'm saying down is positive because the rocks never go up, so it's just simpler just to make everything positive here. We do also know that both rocks really are going to drop the 55 meters. So that's the same for both of them, that they're going to drop down by that much. Okay. And then second rock, we are going to be solving for its initial velocity. And then it still has these same two givens here. Okay. Well, when you're trying to solve for this here, you're trying to work backwards and figure out how you're going to find the velocity in the y direction. We don't know how fast the rocks are going right before they hit the ground. So when we're looking at our list of equations, we can't use, for instance, one that has v y in it because we don't know that either. That means that we're going to need to know time in order to solve for the initial velocity of the second rock. Well, we don't know that, but we could solve for the time that it takes the first rock to fall and then subtract the 0.5 seconds that sort of head start that the first rock gets. So let's do that first. Solve for time that gravity would take to pull that first rock down. Okay, so I'm going to use the equation that doesn't require me to know the final velocity of that rock. So I'm setting this equal to okay. And here I know again that it's fallen 55 meters. This term will drop out because the initial velocity was 0. And then I have acceleration due to gravity times time squared. I keep sometimes writing the delta t and sometimes writing regular t, sorry. Okay, so if we solve that equation algebraically, we divide both sides by 1/2 times 9.8. Remember to take the square root at the end so that you solve for t. If I get 3.3 or 3.4 seconds, I'm going to keep an extra sig fig around. Okay, so then that's great because that tells me that the time that if they're going to catch up, if the second rock is going to catch up to the first rock, then its time is going to be 3.35 seconds minus 1/2 second if it's just going to barely catch up. Okay. If we do that subtraction, we get 2.85. Again, I'm keeping an extra sig fig around here just for grins. Okay, so that's the time that the second rock has available. And then that lets us solve for the initial velocity to cover the same amount of displacement. So again, I'm going to use this equation for the second rock. Okay, 55 meters. This time I'm leaving the initial velocity as a variable here. Don't forget the squared with the time. Okay, and then I'm simply solving for Vy naught, which I get to be 5.3 meters per second. And because velocity is a vector, technically I should be drawing arrows here, and that is thrown down. So Galileo's going to throw that down quite quickly, and we're done.